thank you all for being here. I'm Georges. I'm a principal consultant at Mandiant, part of Google Cloud now. I'm based in Paris, and I've been doing this for a bit more than 8 years. I started doing pen tests, red teaming, and then transitioned a bit towards OT security and through assessments and advisory. I worked in lots of sectors: energy, production, distribution, aerospace and defense, which is one of the main sectors in France, automotive, mining, and some other. So let's begin. What is operational technology? Actually, if you look at the definition, you might have one definition per person you speak to. Some people will tell you it's everything that's not IT. But if we look at the definition of the Forrester, it's hardware and software that detects or causes changes in industrial equipment, assets, processes, events. And the objective of OT is to monitor, control physical process, optimize efficiency, productivity of industrial operations, and then ensure safety and reliability of these operations. And one of the things where it begins to be different from IT is the devices that we find in OT. We have PLCs where we put the logic, we have HMIs where some operators can control the process on a local level, and then we have the actual physical machines. It can be valves, anything, sensors, actuators. And so since OT it's digital equipment, it needs to be secure. And so why does securing these OT devices matter? We have many points. First, it's operational disruption. Attack on OT can halt production lines, shut down critical infrastructure if these assets are controlling them, cause widespread service outage, as we've seen in some countries on the electrical distribution network. You also have safety risks. If you have a robotic arm that starts swinging around, we have risks to the persons around it. And if we're handling dangerous products, then we have also risk to the environment around it. You can also have financial loss, especially in manufacturing. If production lines are stopped, then products are not manufactured anymore. And finally, of course, reputational damage. Any attack on any company can make the news and impact the reputation of the company. And so securing these OT devices, it's not as straightforward as one might think. And you have many challenges. First of which, legacy systems. So when we invest in industrial equipment, it's investment on 10, 15, 20 years. But when we buy the equipment, we'll have one version of the software. And in a few years, it's going to be obsolete, and we have to deal with that. We have proprietary protocols. Many of these devices are communicating in some black box protocols, and we don't often, sometimes we don't know what these protocols are doing, so it's hard to secure them. There are a few initiatives to standardize a bit the protocols that are used in field devices, and Google Cloud is one of the participants in these discussions, but today it's not really the case. We also have limited visibility. One of the most widespread ways to protect OT is to isolate it. So we lose the visibility that we can have on these systems, so we don't know what there is in there, so it's hard to secure it. And also we speak about the skill gap. Often we have operators, we have engineers, but it's hard to find people who have cybersecurity and operational skills. One of the challenges also is some of these systems are not really defensible. So when we look at them, we have like shared passwords, weak passwords. They do not even support stronger passwords. If you look at the networks, often you have maybe a firewall, but then it's a flat network. It's a moving environment. Sometimes you have maintenance people coming, trying to connect to the systems without going through the remote access infrastructure. So it's like a moving environment with lots of stakeholders, and it's not always easy to know what to do to secure it. And since I come from France and Europe, we also have government regulations. Every few years, we have new regulation that has to be taken into account to secure these systems. In France, we had LPM. We're going to have NIS2. We have CRA for the products. So sometimes it can be hard to harmonize all this. And so when we're trying to secure these OT systems, we have to look at the key differences between them and IT because we're not going to have the same strategy to secure them. When on IT, the focus is on mainly confidentiality, integrity, availability. On OT, it's going to be safety, reliability, and then availability. In some industries, confidentiality can be also one of the main focuses if industrial process is confidential. In terms of systems, on OT, we're going to have physical processes, industrial equipment, while on IT, it's mainly storage, processing, communication. Time sensitivity might be one of the main objectives for OT. So sometimes when we try, for example, to install some agents on the machines, if the agents are consuming CPU, RAM, it's going to impact the time objectives that we have for the process, which is not often the case for IT. And like we said before, we also have the legacy of systems. We have obsolete systems often on OT, which is not, it could be the case on IT, but in a lesser measure. And sometimes one of the main obstacles that we might face when trying to secure OT is that there are some widespread myths around it. One of the myths is our OT systems are not connected to the internet, so we don't have a risk. In reality, if you try to do some Google searches, Google Docs, or you look on Shodan or just scan large IP ranges, you're going to see that you find OT equipment on the internet. And I worked on a wind farm a while ago, and so the company that owned the assets, the wind turbines, they had like all this remote access, which is secure, but actually the turbine manufacturer also had access to do some maintenance, and this access was like just exposed on the internet. So sometimes it's not like a prerequisite, that the fact that OT is not connected to the internet. One might think that just putting a firewall between IT and OT is enough to secure these OT systems, but if we look at the latest vulnerabilities, we have one critical vulnerability that dates from a few days ago, and this is supposing that the filtering rules that we put on the firewalls are enough, and that they are reviewed and they're not permissive. One might think that we have safety systems, physical fail-safes that will protect us from having any catastrophe. But if we look at the actual state of these systems, more and more we have integrated control and safety systems. And these safety systems are more and more digital. So if we compromise the control systems, we can also compromise them. And finally, the myths: we are not a target for nation states. But there are not only nation states operating in the field. We have more and more hacktivism. Sometimes it can be collateral damage. And if we look at the Mandiant investigation numbers, we have more and more OT attacks, and all markets and all sectors are targeted. And if we actually look at the trends and the emerging threats, one of the main trends is the rise of hacktivism, especially since the Ukraine war. And we see that also in the Middle East. And if you look at the percentage of attacks which come from hacktivists on OT, so before 2022 it was not much, which is 12%, but since 2022 we have 77% of attacks on OT which come from hacktivists. We're not saying that these are the most impactful attacks, but we're saying that there's more and more focus from hacktivists on OT. We also know, of course, the geopolitical considerations of hacking OT. We saw it in Ukraine since 2014. And cyber is more and more a tool of statecraft, and it's used to advance nation-state interests. And we see it, for example, with Russia, where there's collaboration with some scientific institutes to build toolkits like Triton, which target specifically OT systems. And finally, there's the ransomware issue. Ransomware will not always target OT. Often, like we saw in Norsk Hydro case, it will target IT systems and OT as a collateral, or sometimes like the Colonial Pipelines case, where the ransomware was on IT, but then OT had to be stopped just in case to avoid propagation. So we have these systems that are hard to secure. We have more and more threats on them, but at the same time, the attack surface is increasing. And there is more and more focus on connecting these systems and environments to IT and to the cloud. And we have a few examples that we've put where these systems are being connected. It can be manufacturing systems, it can be OEMs like Siemens, and we have a case where Renault and Google have an alliance to connect vehicles to the cloud, and vehicles are actually now like software-defined vehicles. They're just like code that action wheels and the car, and the software is connected to the cloud. So why increase the attack surface? Why connect OT to the cloud? We have a few use cases that are common in the field. First, data management. Sometimes it's easier to just collect and monitor data from a cloud platform, or have backups in there, or do analytics. And you have a few cases, like the Australian company who sent data to the cloud to benefit from the processing power it has on the cloud and that it does not have in the plant. You have the use case of remote access control. Sometimes it's more convenient to have the control console in the cloud and to use it to send commands in the plants and on the process. And you have more and more OEMs having tools on the cloud. And finally, the predictive maintenance use case, where some physical data points are sent to the cloud to do some processing on them, to detect and anticipate failures and anomalies. And of course, I mean, this is done for financial savings, service quality, feature quality, processing, as we've mentioned, convenience. Sometimes there's an Industry 4.0 agenda and the company wants to connect to the cloud for that. But what about security and all that? So one of the ways to address it is to, so in the past we had this, and we talked about it in the myth, is that we were saying we just put a firewall between IT and OT, and our OT is going to be secure. This is like a castle-like security model. So we aim to prevent the attackers of entering our OT system, and yeah, so the goal is to protect our assets in OT like that. But the main problem with that is that if we increase connectivity with IT and the cloud, then we have more and more breaches in the model, and at one time it becomes impossible to maintain in time. It also faces the issue of having sometimes many maintenance providers that go on site, try to connect USB keys to the systems, laptops to the network, so it becomes more and more difficult to handle this moving scope with a castle-like security model. And so it's important to have, so we call it a museum-like security model, but it's more like as a metaphor. And the goal of this image is to say that we don't want to isolate our OT from everything. We have to authorize people connecting to our OT assets, but these connections have to be monitored and the assets have to be monitored also. So we have a model of defense in depth, where we have visibility on assets, we have detection in depth, and we want to have timely incident response if we detect any anomaly on OT systems. And examples of having this detection in depth, and it can be a catalog of measures that you implement depending on the system and the needs of security on the system. Like having maybe physical security that mitigates some of the logical security measures that you cannot implement. It can be having policies and procedures so that people know what to do and not have risky practices on these systems. can be segmenting OT environments into secure zones and having secure communication channels between these zones. Of course, it can be malware protection on the systems and the assets that can allow that. It can be application control, USB blocking, or even patching if it is possible to do. And we talked about detection in depth, and it's really important to monitor our OT environment and have tactical detections. This can be, for example, communication between two assets that do not communicate between each other in normal time. And it can be communication in hours where no one works in the plant at that time. Also, if we are having Linux and Windows systems, it can also be monitoring events and regular syslogs and trying to build detection use cases on this telemetry. And in order to implement these measures, it's not about just like defining a service catalog, then pushing it to the business and trying to implement this on the OT assets. It should come from a structured approach, and this is why we're speaking about a cybersecurity management system. And it's really a journey. It's not like a task force that can do this one time and then forget about it. And one of the first steps, which is really important, is define the scope and objectives of the program. One of the main issues that we see at some of the clients that we have is that they're going to look at part of the scope. So, for example, they are a manufacturing company, so they're going to look at the devices that are actually manufacturing stuff, but they might forget building management systems in which these systems are hosted. And if we don't have any lighting, any electricity, then we cannot produce either. So it's important to identify the exact scope on which the management system is going to operate, and identify the different stakeholders that you're going to have on these scopes. So do we have to involve engineers, automation people, operators, IT on the shop floor? And it's really important to have a good inventory of the different interactions that you're going to have with different stakeholders to onboard them in the approach that you're going to have. One of the important points in there is also convince management and leadership of the importance of having this management system, because without them, you're not going to have the budget and commitment of the company to support you when sometimes you need to take decisions. And this is where you also identify compliance requirements that you have on your system so that you can then take into account these requirements. Once you've defined the scope, this is where you begin doing the risk assessment that will allow you to identify the vulnerabilities that you have on all the assets that you've identified as being part of the scope. And this is really important because this will drive all the roadmap that you're going to build afterwards. And this is where also you identify the likelihood of exploiting these vulnerabilities in order to also prioritize the type of roadmap you're gonna have. The goal is not to just have a list of vulnerabilities that are not prioritized, and assessing the likelihood of exploiting a vulnerability on a specific asset will allow you to have this prioritization. Once you have done your risk assessment, then you can build a roadmap and a catalog of risk mitigating measures. And this is really important because there is no one-size-fits-all. You're going to have a list of countermeasures that you're going to want to implement, and what you're going to implement really depends on the system you're implementing on. Once you have this, you implement the measures, and then you have to monitor and evaluate the performance of what you've done. So this can be an assessment, it can be a pen test, a red team, where you're actually going to test to see if the countermeasures you've implemented are efficient in mitigating the risk that you assessed initially. And we could have put a line because there is a feedback loop. So if you identify any measure that's not efficient, then you can go back to implement the measure and fix this before continuing. And so this is what done, let's say, on a cycle of 2-3 years, but it's also important to see how the market is moving and follow threat intelligence, for example, in order to see the new threats, the new vulnerabilities, and then you can loop back the risk assessment and start all over again. So some of the costly mistakes that we've seen at our clients so for example, it's starting the CSMS on a small scope, then try extending it. This is really duplicating work because you're going to do the same work that you've done the first time, you're going to do it again for the other scopes. So it's really important to try to involve as much assets and scope, the bigger scope you can since the beginning. One of the other mistakes is just doing audits and pen tests and then having a report with some recommendations and just like functioning like this without having an ongoing process to manage the risk. Because you might miss something because the auditor and the pen tester, they're just going to look at the systems from their own perspective and they're not going to cover everything you have in your OT environment. One of the main points, and this is why involving all the stakeholders from the beginning is important. Awareness and cultural change is the cornerstone of any CSMS. If the people in the shop floor and in OT environments are not involved in the approach, they're going to have bad practices and you're not going to maintain your security level on the level you want it. Also, this is an ongoing effort. You can just reach a maturity level on stuff. It has to be monitored and then improved. Also, sometimes you can look at generic best practices that you might find on the internet or that Gemini can give you, but it's important to adapt these recommendations to the actual systems you have. So if you find recommendations about patching is not always possible on all the systems, especially on OT. Deploying agents also, like if the system is time sensitive, you don't want to be using CPU for that. And the most important point is capitulate at the first difficulty. We find many clients that have just like lost faith. They're going to say, engineers and operators say that it's not possible. And it might be true, but it's always important to have an open mind, be a bit creative to find alternative solutions to mitigate the risk. So if the risk cannot be mitigated with some measures that you can do logically on the system, maybe adding physical security around it can be a solution. Maybe adding passive sensors can be a solution. Maybe adding some agents in some case can be a solution. But it's really important to have an open mind and be creative.